This is an interesting question. What we start out with is a beaker that contains two ions. We have silver plus and we have barium 2 plus. And we're going to be adding to this beaker some potassium chromate. It's a soluble compound that's going to produce potassium ions and chromate ions. Now the chromate ions are what we're going to focus on because both silver chromate and barium chromate are insoluble. So as time goes on, the chromate ion concentration is going to be increasing due to the release of chromate, and the question is, where do these two metals start to precipitate out as the chromate? Alright, so we're going to be looking at both barium chromate and silver 1 chromate. So for barium chromate, solid, equilibrium is with barium 2 plus and chromate. So our IP we want to be equal to KSP because that's when the precipitation is going to occur. And it's barium 2 plus, which is set, and chromate, which is slowly increasing. So we want to find the chromate ion concentration where our precipitation is going to start to occur. So we're going to solve this for the chromate ion concentration. That's going to equal to KSP divided by our barium 2 plus ion concentration. And our KSP for barium chromate is given to us as 1.2 times 10 to the minus 10. Our barium 2 plus ion concentration is given to us in the statement of the problem as 0.20. So the chromate ion concentration where precipitation starts to occur is 6 times 10 to the minus 10 moles per liter. Now for the silver chromate, and again we want to solve when the ion product is equal to the KSP, because that's going to be our saturated solution. Any higher and the precipitation will start it. It's going to be equal to silver plus ion squared times our chromate ion concentration. So we're going to again solve for the chromate ion concentration. That's going to equal KSP divided by Ag plus squared. So Ag plus is 1.1 times 10 minus 12, and we're divided by 0.2 squared. So the chromate ion concentration is going to be 2.75 times 10 to the minus 10 moles per liter when this just starts precipitating out. Okay, so let's compare these. We find that we need a lower concentration of chromate to start precipitating out the silver chromate, So this will precipitate first. And it'll start occurring when CrO4 2- ion concentration gets a little bit larger than 2.8 times 10 to the minus 10. And when the chromate ion concentration gets up to twice that, about 6 times 10 to the minus 10, is when the barium chromate will begin to precipitate.